Okay, as you can see, I'm in cycling gear. So right now I'm at the bottom of Alexander Palace in London, and I'm going to see if I can use trigonometry to calculate the gradient of this hill climb. So roughly speaking, you'll see it all over the country and maybe a bit more overseas. But you see a lot of signs that give you the percentage of a hill. Quick Google. Imagine 100% of a hill. It's actually the gradient 1-to-1. So you pictured a XY graph, y equals x. For every square you go along, you go one square up. So that's 100% slope, 100% gradient, which gives us an angle of 45 degrees. So 100% is a 45-degree slope. So essentially, I'm going to climb up this hill, and I'm going to use trigonometry. And the idea is, I'm going to cycle up the hypotenuse, and I'm going to have an elevation on my Garmin. And the idea is, my elevation is my opposite of my angle, and my opposite over my hypotenuse is the distance I bike up. And the idea is, I should be able to calculate the angle. Sine of the angle equals opposite over hypotenuse, which is elevation over the distance I bike, and then sine to the -1 of that answer to give me my angle. So let's find out. I had a quick Google. It's roughly, depending on where I start, I'm going to start just back there. It's roughly 1.1 kilometers up, and the elevation is roughly 48 to 50 meters. So let's find out. Strava tells me is roughly, sorry, video cut out. So Strava tells me it's roughly 1.1 kilometers, 47 meters elevation with a gradient of 4.7%. I've not done the maths yet, but that's roughly anything between 2 and 3 degrees going up. Looks a lot more than that, but yeah, I'll see you at the top. I'll get some data and we'll go from there. Okay, I'm going to hit start in 3, 2, 1. So there we are, hit lap, and we're just going to go climb up here now. How hard can it be? So you can see here, my lap distance is going to be my hypotenuse, and we started at 50 meters. Nice number. So now I just have to climb to the top and act like I'm not out of breath already. So. So you can see the steeper it gets, the more power I put out. So just there, I'm sat at about 400 watts. So in cycling, the better your power, the weight, the lighter you are, the more watts you can put out, the higher you climb, faster I should say. So 500 meters. We've climbed 35 meters. So the idea is you picture a right angle triangle. I'm just riding the hypotenuse of the hill. Okay, so we've got a nice 900 meters climbed. I'm going to post this here, switch to my phone. So I've got the Garmin here, and you can see we're going to round it up to 900 meters, and my elevation, I climbed up to a height of 93 meters. So essentially the hypotenuse has a length of 900 meters, and my opposite side has a length of, well, it was 93 before I lifted it. So 93, take away 50, 43 meters. So hypotenuse is 900 meters. The height, or the opposite of the angle, is 43 meters. So we just need to do a bit of math now. So I'm going to pause the video now, do some maths on my phone and put back on. So I've done the maths. So sine of theta is opposite over hypotenuse. So elevation over the distance I climbed. So sine of theta is going to be 43 meters over 900 meters. Therefore, the angle, if you picture a right angle triangle, it's going to be sine to negative 1, 43 over 900, and that gives us an angle quite small of 2.73 degrees. So what's the gradient as a percentage? Well, we said at the bottom of the climb that the percentage 100% is 45 degrees. We go 1 for 1 up a gradient, the slope. So 2.73. So here we have a nice satellite image of the hill I just climbed up. So what do we know? I started here, and then I biked all the way up this hill, all the way up Alexander Palace Way, all the way around, and you saw me pull in just here. So that's my end point here. End. So the idea is, this is my hill, and I've already written at the top angle of elevation, which Cycling Me never said, because Cycling Me was quite tired biking up a hill. So angle of elevation is what I was climbing up. So if I use this pink line to represent my hypotenuse, like so, and I climbed up 900 meters, but we know that my elevation was my height of my climb. So there we are, let's make this nice and looks nice. So my angle of elevation, we worked it out to be 2.73 degrees. We'll go 2.74 to 2 decimal places just for my picture. And my height, my elevation was 43 meters, and we did that using sine of the angle is opposite of the hypotenuse. So now this is cool. So we want to work out the percentage gradient on average of this hill. How do we work that out? This is where it gets really cool. So we've got the angle of elevation. That's lovely. So we know that the gradient of a slope is the change in y over the change in x. So if you picture a xy graph, well, this is where it gets really cool. That's your change in y, which is also your opposite, and change in x, guessed it, is your adjacent. Here, adjacent. What do we know? Well, we know that tan theta equals opposite over adjacent, which we've just said, therefore tan theta equals your change in y over your change in x, which equals our elevation, over our horizontal ground covered. So we now know, therefore tan of theta equals our gradient. That's what gets really cool with trigonometry. So I've got on my calculator now my angle of elevation. For accuracy, I'm going to put in my calculator angle of elevation. I'm going to go for pure 100% accuracy here, equals 2.738507568 degrees. So tan of my angle of elevation, just for the sake of math, I'm going to write 2.74, but in my calculator I'm putting in this value here. Tan of our angle of elevation equals, drum roll please, 0.4783. We'll go for that for 4 decimal places. That's our gradient, 0.4783. To get it as a percentage, all we have to do is times it by 100. Therefore, Oh, sorry, I've written that wrong. I forgot a little zero. That's really important. 0.04783 times it by 100. Our average percentage of the hill is 4.78% to 2 decimal places, which is lovely because cycling me at the beginning made a estimate of 4.7%, and there you are, maths in real life. I think that's pretty cool. And there you are, a bit of trigonometry in real life. I think I've earned myself an ice cream behind me, and I'll see you next time for whatever video I come up with. I hope this helped. And now for the fun bit, going down the hill. So wait for a gap and I'll get going. There we are, bottom of the hill. See you next time.